Okay, we're going to go over section 10.5, and before I do that, I want to do a review of some of the things that we've learned. One of the most interesting concepts we learned last time was the concept of slope. So if I have a line, then slope is more or less the rate of change between the rise, so this is a line, it goes on forever, and the run, and that is our slope. And we learned how to find the slope. So if I'm given 2 points that lie on the line, x1 and y1, and another point, x2 and y2, then the slope of the line is given by the equation y2 minus y1 over x2 minus x1. The thing that we wanted to remind you is that these negative signs right here are inherent in the equation. That means if y1 is negative or if x1 is negative, they have to bring their negative sign with them. They can't use the one that's already there. So here is an interesting question. Let's actually take a look at GeoGebra really fast. So here I'm just going to draw a point right here. And we see that through that point, as we've actually seen before, that there are an infinite number of lines that you can draw through that single point. However, if I fix a slope, then there is only one line that I can draw through that point. So the question is, or what we discovered is, if I know a point and a slope, then I can draw a unique line through that point. So our goal today is to do just that. So our goal is going to be twofold. We're going to look at something called the slope y-intercept, intercept form of an equation of a line. So that's one of the things we're going to do. And once we're given an equation in that form, our goal is to be able to graph the line. But let's remind you of some other important things. First, that when I'm given a line, so here's a generic line, and I thought I'd change color, a point on that line or another point on that line is given by a specific value of x, which I'll call x1, and a specific value of y, y1. For example, 3 and minus 1. And that is true for every single point that is on that line. Moreover, given an equation for that particular line, where a and b and c are real numbers, but a and b are not both 0, when I plug these values in for x and for y, I get a true equation. The other thing I want to remind you that's really helpful, just keeping that in mind right there will guide you through a lot of problems. And the other thing is, when we're in the rectangular coordinate system, we're no longer dealing with with numbers. Rather, we're dealing with points. Everything has two addresses, the x address and the y address, or formerly known as the x coordinate and the y coordinate, or sometimes we'll call it the first coordinate and the second coordinate. So, in particular, one last thing, given, for example, so I just learned how to use this. It kind of works. For some reason, it gives me a straight line, but then it peters off at the very end. So if I have a coordinate system, and I do know how to do this, I can make it actually bigger, and I have another line. It's not perfect, but I don't want to go to GeoGebra and draw one. I'm being lazy. And I better make it a little bit lighter. And I draw a line through it. Then the point where it crosses the x-axis, which is right here, always has a 0 for the x direction and some value of y for the y direction. And that value of y is simply how many its distance from the origin. So, good. Let's move on. So, there's two different ways we're going to do this. So, suppose you are given the slope. The slope of a line is equal to 2. Well, one of the first things you're going to do is you want to turn that into a ratio of rise over run. And here I start to write rise twice. Rise over run. So let's do that for a few examples. Rise over run. So if the slope of a line is 2, then 2 is the same as 2 divided by 1. So that is the rise over the run. The rise deal with changes in y values, and the runs deal with changes in x values. So the runs have to do with horizontal distances, and the rise has to do with vertical distances. So remember, we also use the letter M to refer to slope. So suppose you have a slope equal to 5/3. Well, then that's really simple. That's equal to the rise over the run. So it has a rise of 5 units and a run of 3. And again, conceptually, the rise deal with y changes and the runs deal with x changes. So suppose you have a slope of 1/2. Well, again, the rise is 1 and the run is 2, and that deals with y's and x's, changes in y's and x's. So let's continue on. So here is our dilemma. Suppose you know the slope M of a line is 3/2, and the y-intercept of the line is 0, 4. Graph the line. So I'm going to show you two different ways to do this. And that's really exactly the problem we're going to be doing in 10.5, except we're going to be given an equation of a line where you can literally read off from the equation, literally read from the equation without doing any algebraic manipulation, the slope m and the y-intercept. So here is the first way we'll do it. So let's kind of draw this visually. Here's my x, and here's my y. And I'm going to say that the point 0, 4 is right there. So for us to actually graph with our graphing tools, we don't use angle measurements or anything like that. I really need another point, either another point up here somewhere or another point down here somewhere, so I can draw with a straight edge through that point that I know. This is my y-intercept. So how do I do that? Given the slope and a single point, and for us, for now, it's always going to be the y-intercept, how do I find that other point? Here's two ways we're going to learn how to do that, and you can pick and choose. So what we're going to do is remember that 3 halves is the change in the y's, and the 2 is the change in the x's. So since 2 is positive, I'm going to start at my known point, and I'm going to go over a distance or 2 units. And then since my 3 is positive, I'm going to go up 3 units. And right there is going to be my second point. And I can draw my line through those 2 points. So you just simply start with your known point. In our case, that's the y-intercept. You use what you know about the slope, and then you go in that direction. 2, because 2 is positive and it corresponds to the x's, so you go in the positive direction for the x's, and then you stop and go up 3 different units, or 3 different a distance of 3 in the y direction. So let's do another one that way. So in this case, we know that our slope m is equal to minus 5/3. I made it minus on purpose. Remember, m stands for slope. This is our slope. And suppose that your y-intercept, so what do we know about the y-intercept? It's a point. So it's not a single number, it's a point, and the x value is always 0. And our y-intercept is 0 minus 1. So we can try to sketch that. I'll try to sketch it here. Okay, so we're going to say this point right here is 0 minus 1. That corresponds to our known point. So what am I going to do about this negative out in front? Well, remember, if I have a fraction a over b, if I want to find its negation, I have two different choices. That's the same as minus a over b, which is the same as a over minus b. In other words, when I have the negative out in line with the division line, I can either take the negative and put it up here with the a, or take the negative and put it down there with the b. So you decide up here. I'm going to go ahead and put it up here with the 5, and here's the 3. So I know my point, so I know the line is going to go through that point. Now I'm going to erase that because it's going to get in my way, I fear. And we know that the coordinate here, that this is where the line crosses the y-axis. So remember, this is my x-axis. This is my x-axis. This is my x-axis. Why is it not writing? Do that. Now is it going to write? Yeah, that's my x-axis. And this is my y-axis. I think I had it too fine. And this is the coordinate. If I put it over here, it won't be in the way. 0, minus 1. So, remember, the minus 5 is my rise, and the 3 is my run. The rise correspond to y's, y direction, and the run corresponds to the x direction. So what I do is I start right there, and I look at my run, and I go over 3 units. So I'm going to say that's 3 units in the x direction. Now I look at my y, and that's a minus 5. So I go down 5 units, minus 5 units, and there's my second point, and then I just draw my line through those 2 points. So I don't know what this tool does, some kind of artsy thing. This isn't really, this is made to actually sketch pretty drawings, I think, not teach math, but it's the best I've been able to find. But you can extend this line easy enough on your own. There, good enough. So that's one method. So let's do another method. So if you like this method, we'll keep it up. I'll try to use both methods in the problems that we have, because we're only doing the goal 1 and goal 2 for this particular lecture. So the next method, again, we're going to be given the exact same thing. Our slope is going to be 3/5, and our y-intercept is going to be equal to 0 minus 10. So what I want to do is find another point on the line. And actually with this method you can find an infinite number of points on the line. You can with the other method too. So what I do is I take my y-intercept, and I'm going to be adding points, but it's really easy. And I'm going to create what's going to be called an adder point. So I'm going to put my adder point. This is my adder point. And the thing to remember about the adder point is not necessarily a point on our line. As a matter of fact, the only time it would be a point on our line is if the line goes through the origin. Any other time, it won't actually be. So that's the reason I'm going to call it an adder point. And it's going to have a value x and a value y. And it's an adder point because I'm literally going to add points. And I will show you how. You think, well, how do you add points? I know how to add numbers. And the result of this sum of points is another point that is on our line. So this is the given point. So given point, and the given point for you guys is always going to be the y-intercept, but it doesn't have to be. It could be any point, but for you all it will be the y-intercept. So the given point plus the adder point is equal to another point that you don't know about that is on our line. And this is what we want. I want 2 points on the line. So how am I going to find the x and y at my adder point? Well, that's going to be really simple. What I'm going to do, remember the 3 is my y's, it's my rise, and my 5 is my run. So the 5 corresponds to the x's, so I'm going to put it right there where the x goes. Remember, every point is a form of x, y, and the 3 corresponds to my y. The only difficulty of this is you've got to put the denominator in the x spot and the numerator in the y spot. Now, how do we add points? It's really simple. We just add x's and x's. So 0 plus 5 gives me 5. Minus 10 and 3, minus 10 plus 3 is minus 7. So I just add similar things. I add the x's to the x's and the y's to the y's, so I don't miss anything. So 0 plus 5 is 5, and minus 10 plus 3 is minus 7, and here is another point on our line. So I have 2 points, 0 minus 10, 5 minus 7. I can plot them. If those 2 points are close together, I can always take the new point I just discovered and then add my adder point, which is always going to be the same. Once I found my adder point, it's fixed, and I get yet another point on the line. 5 plus 5 is 10. Minus 7 plus 3 is minus 4. So now I have 3 points on my line. My y-intercept, another point, and another point. So we're going to use both of those methods to do these exercises. But before then, I've got to introduce you to the main attraction. So in another lecture, I showed that the general equation in 2 variables of a line was given by ax plus by is equal to c, where a, b, and c are real numbers. There's only one but, and that but is a and b together are not both 0. And we saw quite a few equations of lines in this form. But what we can do is the following. There's one caveat. As long as b is not equal to 0, we can solve. What are we going to solve? This equation right here, equation 1. for y. The result, and you don't have to know this, but I'm going to give it to you anyway, is y is equal to minus a over b x plus c over b. If we let m equal minus a over b, and we let c over large B equal small b, that results in the following equation of a line. And it is in this form. Y, whoops, I want yellow. Y is equal to mx plus b. And this is the only thing you have to know. This equation right here is called the slope y-intercept form of an equation of a line. Sometimes we're really lazy and we just call it slope-intercept form. So what's so special about this form? M is a constant. X is our variable. I remember our variables are y or x. M is a constant. M is equal to our slope. And B is the non-zero value for the point, which is our y-intercept. So remember, B is a real number. Y-intercept is a point. But we already know the first coordinate of our y-intercept is 0, so B is the value that goes in the y slot of our point. By y slot, I mean y coordinate. So let's look at some examples. So y is equal to minus 1/5 x plus 20. The slope m, so that's y is equal to mx plus b. So m is equal to minus 1/5. That is our slope. Our y-intercept, I'm just going to call it y-int because I'm lazy, is the point 0b, which is 20. So look, I have a point, and that point is my y-intercept. I have the slope. So if I write the slope as minus 1/5, I can create my adder point. 5 minus 1, and I can find immediately another point on the line and hence plot it. 0 plus 5 is 5. 20 minus 1 is 19. You're saying, well, what happens if I had actually chose to write minus 1/5 the other way, is 1 over minus 5. That's still going to work. 0, 20 is my y-intercept. And I'm going to create my adder point. I'm not going to write it in a different color anymore. I'm going to choose that to be 5 minus 5 and 1. And I'm going to get a different point, but that's still going to be a point on the line. So 0 plus a minus 5 is minus 5. And 20 plus 1 is 21. So I actually have 1, 2, 3 different points on my line. So let's look at some actual examples. So we're going to, I'm going to put that at the very tip top here. So you're given, so in this case, you're always going to be given the equation of the line in slope-intercept form. And that makes it a lot easier. Now when you're in intermediate algebra, you'll have to derive it from another form if you want it in that form. So remember, that's what's given us. Y is equal to 1/2 x plus 3. So underneath of it, until I'm getting used to it, I'm going to write y is equal to mx plus b. So now let's extract the information I want. M, which is my slope, is equal to 1/2. And remember, that's y over x. Just kind of remember that. My y-intercept is a point. Always remember it's a point. It's equal to 0, b, but my b is -3. So let's find another point. Okay, well, and we're going to graph this. So we're going to graph this 2 different ways. So the first way we're going to do it is we're going to find another point using the adder point method. So I start with my known point. And literally, if you want to do it this way, it might be easier. Just add them by stacking up. Create your adder point. Just remember, your adder point isn't necessarily a point. So my x value is 2, and my y value is 1. And I get my new point down here by just adding. 0 plus 2 is 2. -3 plus 1 is -2. So now I have another point. -2 and -2. So that's easy to plot if you have your graph. But let me go over to GeoGebra and we'll do these together. I'm just jotting down the information because I'm going to change screens. And I'm going to do it now by using my other point. And then we'll do it the other way, not using the adder point method, but just finding the other point directly from the slope. Pencil turned upside down. No, you don't need to see that. You need to see this. Let's delete and delete. And we'll delete that. So let's find my first point. It's 0 and -3. So let me write in my first point. It's 0 and -3. And by using my adder point, I found another point was 2 and -2. And from that, I'm good to go and I can draw my line. So that's using the adder point method. So let's do another method. So here is my y-intercept, 0 and -3, and my slope is 1/2. So that means I go over in the x direction 2, and then I go up 1, x direction 2, and y is positive, so I go up 1, and I put my point there, and it's the exact same point I just got, and I draw my line through it. Here, what you're going to do is you're going to come down and plot your y-intercept first, which is 0 minus 3. So there's this is 0. This is 0 minus 1, 0 minus 2, 0 minus 3. And then if you want, you can go over, our slope is 1/2, go over 1, 2, and up 1, and put a point right there, and draw your line through it. Or just start out with 0 minus 3, and then find 2 minus 2, which is the exact same point, which we got using the add or point method, and put your point right there and draw your line through it. So let's do another one of these. So I'm given y is equal to minus 1/4 x plus 2. So you should really do this until you're really used to things. Underneath of it, write your general form of the slope-intercept. Y is equal to mx plus b. Now, collect all of your information. M, our slope, is equal to minus 1/4. So I'm going to have to make some choice. So I'm going to make it 1 over minus 4. It doesn't matter. You'll get a different point, but there's an infinite number of points that lie on that line, and the different point you get will be one of those infinite number of points that's on the line. And the y-intercept is a point. Remember, its first coordinate is 0, and the next coordinate is b, my b value, which is 2. So this is a known point. We know the line actually goes through this point. So starting with that point, I'm going to add, I'm going to do it vertically, my adder point. So my x value is minus 4, and my y value is 1. And when I add those together, you can just ignore that little mark. I was going to do a horizontal addition. Vertical's way better. Then we just add. 0 plus minus 4 is minus 4. 2 plus 1 is 3. So another point is minus 4, 3. Notice that we could repeat this indefinitely. What stays the same as my adder point? This point right here. So if I wanted to find yet another point, if those two points were too close together, I could take the result of my addition, put it up here, minus 4 and 3, then use my adder point again. It does not change. But remember, the adder point isn't necessarily a point on the line, and I add again. So minus 4 plus minus 4 is minus 8. 3 plus 1 is 4. So yet another point, a third point, I now have 3 points, is minus 8 and 4. So let's plot those. So m was equal to 1 over minus 4, and our starting point was 0, 2, and we found two other points, minus 4, 3, and minus 8, 4. So let's go ahead and do that. I'm just going to go ahead and use it, do this in GeoGebra, and I'm assuming that you all are good enough that you can duplicate what I'm doing here in that little bitty graph you have. So I need point. I don't know why did it do that. Yeah, I've not really learned the ins and outs of this thing. Oh my gosh, it's playing. That's weird. It made a little animation there. Anyway, my y-intercept was 0, 2. So there's my first point. And the other point I got was minus 4. So x is minus 4 and y is 3. And I can draw a line through them. But yet another point I got was minus 8 and 4. And indeed, when I find minus 8 and 4, we find it's also on the line. So all three of those points sufficed to graph the line. So let's go ahead and do this with all the rest of them. So you might freak out about this one. So this one is, but don't, because it's just a hidden thing that we're going to bring to light. So this again is extra. I've not been writing. This is 1c. I always forget something. So y is equal to minus 4x. And remember, what we want is y is equal to mx plus b. So in order to get a b there, all I have to do is add 0. Adding 0 doesn't change anything. So my values of interest is my slope m is equal to minus 4. And what are we going to do with minus 4? We're going to change it into a fraction, just like we started doing at the very beginning. And we're going to remember that the numerator corresponds to my y, denominator corresponds to my x. Now, my y-intercept is equal to 0b. So what is the value of my b? 0. This one actually goes through the origin. So we have one point, our y-intercept. And remember what I said about the adder point? The only time your adder point is actually a point on the line is when the point goes through the origin. Well, we're going to discover that. So what is my adder point? Let me do it this way. I'm so used to doing, and I don't know why, it seems to me I should always just go vertical. So my adder point is my x value is 1. Be careful to make sure you get your x value and put it in the right place. And my y value is minus 4. And now you're going to see exactly what I said before. Whenever your line goes through the origin, and we know it does because its y-intercept is the origin, then the adder point is an actual point on our line. So 0 plus 1 is 1. 0 plus minus 4 is minus 4. So it turns out another point is 1 minus 4. It was that rare occasion where the adder point is actually a point on our line. Well, let's find yet another point. So 1 minus 4, the adder point is always the same. And we're going to add these together. So a third point, 1 plus 1 is 2. Minus 4 plus minus 4 is minus 8. So a third point is 2 minus 8. So let's go ahead and plot those. So 0, 0, slope is minus 4. And I got 1 minus 4 and 2 minus 8. So going over to GeoGebra, erasing all existing things. So my first point, it goes through the origin. So I'm going to put a point right there at the origin. Then I found out the next point it goes through is 1 minus 4. So here is 1, and there is -4. So let's draw a line to those 2 points. And let's get some more room. So let's now plot yet another point, 2 minus 8. So here's 2 is my x, and -8 is right down here. And that also lies on the line. That shouldn't surprise us by now. Get us some more room. Now what have they done with us here? And I misspoke. I said it was always given to you, but here I'm being proven that my memory is not so good. So this is 1D. So we're going to do this. You can always there we go, 1D. And the equation we're given is 5x plus 2y is equal to 10. So the name of the game, the theme of this is y-intercept form. Y is equal to mx plus b. So what I have to do is I have to solve for y to convert equation to this form, the y-intercept form. So let's do that. That's not so bad. So the first thing I'm going to do is I want to isolate y by itself. So I'm going to take this 5x here and I'm going to move it to the other side. And when I do so, it becomes negative. That's the price you have to pay. And since I want my mx to come first, I'm going to put my minus 5x right there. And then my 10 is still there, and it's positive. So basically all I did is really I moved my 5x to the other side and snuck it right in there, right in between the equal sign and the 10. So this is what I have. So now what I want to do, I know what 2x is, so I need to know what 1x is. So I divide everything on both sides by 2. So when I divide 2y by 2, that gives me y. And then this minus 5x divided by 2 plus 10 divided by 2. So let's simplify. So this is the same as y is equal to minus 5 halves times x. 10 divided by 2 is 5. And there I have what I was looking for. Y is equal to mx plus b. So my m value is minus 5 over 2. So let's just go ahead and put the negative in the numerator. My y-intercept is equal to 0. It's always 0 first. And what's my b value? 5. So let's go with that. So let's find another point. So I start with my given point. My given point is my y-intercept point. Like I said before, it could be any point, but in this case, this is the point we are given, so we're going with it. Now I create my adder point from the slope. So the 2 is my x value, and my minus 5 is the y value. And we're going to add those. And the result of adding them together is another point that's on the line. So 0 plus 2 is 2, and 5 plus minus 5 is 0. So another point, a second point, is 2 and 0. So let's go ahead and plot those. So going to GeoGebra. So I want to, my y-intercept was 0, 5. So right here is 0, 5. And my next point was 2, 0. 2, 0 is my x-intercept. And we can draw a line through those, and we're good to go. Okay. Now, here we go. So the next thing the last thing we're going to do, so 2a, b, and c, is going to be really, really easy. So we're given the m and the b for my y is equal to mx plus b. And notice we're saying write not the equation of the line, because there's many different equations of a line, but write an equation of the line with given slope m and y-intercept. So the equation form that we want to choose here is slope-intercept form. So we start out with y is equal to mx plus b. So this is number 2a. But we are given that the m value is minus 9 and the b value is 4. Man, that was super simple. Right there, we're done. Now let's do 2b. Again, we start out with my general y is equal to mx plus b. This needs to be memorized. We're given that m is equal to minus 2/3. Remember to put your x there. Plus b, and b is equal to 7. Not so bad. Let's do 2c. Again, we start out with y is equal to mx plus b. And we're given that m is equal to 0 and b is equal to 1/2. So this one needs a little bit of simplification. 0 times x is 0, so that gives us y is equal to 0 plus 1/2, or y is equal to 1/2. So this is a line with slope equal to 0. And I hope you all remembered from last time that that is the equation of a horizontal line. In other words, if this is my coordinate system, this is y is equal to 1/2. So I'm going to say this point right here is 0, 1/2, and hence the line is a horizontal line straight through that point. That is, so again, this is my x-axis, this is my y-axis, and this line right there is the line given by the equation y is equal to 1/2. And one other thing And we're going to do 2D. So again, we go y is equal to mx plus b. And we're given that m is equal to minus 5/2. I'm looking right here, people. And it has to be multiplied by x. Be careful, put your x in line with the division line. The x is not down here scooted next to the denominator, it's right there. And b is 31/2. And you could simplify it, but you just leave it exactly like it is. Okay, so let's check to make sure I've got everything. That is indeed everything we were supposed to do. So a pretty straightforward unit, and if I'm not mistaken, this ends our unit on lines. What's going to be coming up next is on exponents. And people typically require a lot of practice. Well, it's kind of a mixed bag. Some students get exponents just like that, and other students find it the most confusing thing. But we're going to a different subject. We're skipping chapter 11 altogether, and next time we will actually start with chapter 12.